Let's define what is rapid prototyping according to what is observed in the industry by industry experts. So, what does Terry Wallace, who is an industry expert and market expert, says? He says that he calls it a technology that produces models and prototype parts from 3D models, data, CT and MRI scan data, and model data created from 3D object digitizing systems. Joe Beeman, the professor from UT Austin, says it's direct fabrication of parts, components, or models from 3D drawings without part specific tooling or human intervention. Personally, I think that these definitions are all very complicated. So, here is my definition. You create a 3D CAD model and you have a fixtureless platform and a deposition head or a manufacturing head produces a part from the CAD model without any intervening mold or fixturing. You may machine the part or you may machine the part while the building is going on. Ultimately, when it comes out, you just get a final completed part. That's it. So that's what you would call rapid prototyping or additive manufacturing or 3D printing or solid freeform fabrication. Whatever you want to call it, that's what it is. So, what are the traditional product development techniques? So, they are all for visual evaluation. They have an ergonomic function, and sometimes you just want to see form, fit, and function, and sometimes you just want to make a part to show your customer for marketing presentation. What is this final part design going to look like? So that's what the rapid modeling technique is. And so 3D printing or additive manufacturing is used for that. The ultimate goal for any of these is to look at the part function in actual service. So functional testing. So you want to put it into the actual function and see how many cycles it can run, how much strength it has, whether it meets the standards that you have, whether it meets your design criteria and so on. So you want to look at the functional testing. So, or you want to look at the strength, or if you have a part that if you have a space that this part is supposed to fit into, whether it is going to fit into your particular component cycle or not, whether it is going to fit with another part or not, etc. So, fit of your part. Ultimately, this is where the technology has already taken us. You are trying to make functional prototypes or rapid manufacturing. Rapid manufacturing is the ultimate goal. Rapid prototyping is no longer the goal. But now we will talk a lot about where this technology is going in the future lectures. So I will talk about what are going to be the goals of that. So we have already attained the functional prototyping or rapid manufacturing goal. So that is no longer the sexy thing to do. Most of the time, when we started rapid prototyping in the early 90s to mid 90s, the automotive industry was a big user for this technology. So where did they use it? They wanted to make tooling. So, for example, if you have a new car model, guess how long it takes for the new car model to come into the market? It used to take at least 3 to 4 years for a new car model to be designed, built, and brought into the market and engine tested and things like that. Now it typically takes about a year or even less. So in order to do that, you have to create the tooling, you have to create the masters, you have to create the cores, fixtures, cavities, etc., jigs, etc. So if you have a part that a jig for investment casting, you can use rapid prototyping to create the first 100 prototypes. You want to use the parts for making RTV tooling, rubber molds, urethane molds, epoxy molds, etc., etc. So that's where it started out. But now we are trying to make complete functioning prototypes from using 3D printing or additive manufacturing. So what are the advantages of rapid prototyping or rapid manufacturing for product development? Suppose you want to create a part and it is going to take you 6 months. If you can make those parts in 3 months itself and you can bring this part to the market in 3 months, yes, you just squash the competition. What do they call about competition? It's either do lunch or be lunch. Either you squash the competition or you get squashed by the competition. So in order to do that, you have to be able to bring your product to market faster. And you also want to make the parts better so that suppose you build a part and you find that that tooling, that part doesn't fit or doesn't meet your design expectations. You have to create a new tooling which will cost more. So what do? Sometimes you try to salvage your earlier die or tooling, which means the new tooling is not as good as the old one, the first one. So suppose you are expecting your tooling to last for 20 years, sometimes your tooling will only last for 5 years or 6 years or 10 years. So which means you have to create a new product again, new tooling again in order to meet the life cycle of your product. So by doing this ahead of the design cycle, you are reducing your final cost to your part. So what is the cost of making engineering design changes? Suppose you do that in the conceptual design stage, if it costs you $10, after the product has actually been installed in field or service, it will cost you $1 million. This is a rough number, but you can see what I'm getting at. It's going to cost you a lot of money to make those changes after it has already been introduced into the market. Even this is expensive in the prototyping and testing stage itself. It is going to cost you a lot of money. But suppose you make all these changes here itself, then you are saving a lot of money for not only for your company, you are increasing the profits of your company and so on. The other benefits of 3D printing or additive manufacturing is, suppose you have a part that has been used for a long time and you no longer have any of the engineering designs, engineering drawings, no tooling, none of that, and you just want to replace a broken part. Suppose you have a car that's an antique car and your engine fails. What are you going to do? Can you go and get a replacement part from the market, in the after sales market? You can't. So you have to take your broken part and you have to give it to somebody to make a replacement part from that old design. How much is it going to cost you? Or for example, um, let me give you an example. I mean, I don't know how relevant that is. I mean, but I'm sure that Scott from Tinker can attest to what I'm saying here. The KC-135, the bomber refueling plane that is used by the Navy and the Air Force. What happened recently, about a couple of years ago? They wanted to replace the entire KC-135 platform with another platform. They first went with Lockheed. That order got cancelled. No, I'm sorry. They first went with Boeing, and that order got cancelled because of some potential conflict of interest issues. And then that whole order was given to um Airbus and Northrop Grumman, and Boeing complained again, and again it got cancelled, and the new order was given to Boeing again. But by the time Boeing is able to design it and build it and bring it into the service, it's going to take at least 5 to 10 years, which means it'll be 2025 to 2030 by the time the plane comes into service. But there are existing planes, and the KC-135s are from the 1950s. There are existing planes flying, and these planes have absolutely no drawings. I mean, the parts have no drawings, none of that. Scott, please confirm that. So how do you replace these parts? So you have to re-engineer or reverse engineer these parts in order to build spares. The only way to do that is by 3D printing or additive manufacturing. So what is the traditional product development process? First you take the CAD model, then you have to pre-process it. Your solid modeling software will slice it. Then if you have overhangs and undercuts and things like that, you have to have supporting material that is not the same as your actual material itself. And then each of those slices has to be built, and that has to be designed where the material is going to be laid down. Then you build the part. Then after that you break off all the supports, you sand and paint, etc., and then you deliver to customer. So these are the traditional applications, but now, as I said, it is more of functional prototyping. So these are all the different areas where additive manufacturing is used. I'm sorry about the quality of this picture. I was just cutting and pasting it from the Wohlers Associates website. They won't allow you to copy and paste that, unfortunately, but that's the way it is. Compared to a few years ago, there is a wider variety of uses and uses for rapid prototyping or additive manufacturing. Now, why is additive manufacturing preferred? Why is 3D printing preferred? If you can bring a product to the market fast, even as much as 6 months, your gross profits goes up by 33%. This is an estimate by Gallup, but I think that gross profits are even higher according to me. There are zillions of US companies and many more global companies that are currently using this technology in every field possible. This is a dated data as of March 2001. That's the latest I could get. But there are so many of them. I've lost count of the number of industries that are using 3D printing and additive manufacturing. Automotive industry is still the biggest driver and user of rapid prototyping. But now there is more and more of that being used by aerospace and other industries. In fact, you should go and look up something that happened in 2015 or 2016, if I'm not mistaken, it is 2015 at um, I think it is 2015. Go look up the the word Cobra cars being built by Oak Ridge National Laboratory. They built an actual car on the floor on the conference floor, and that car was driven off by the by one of the people there, and they took it for a spin along on the roads of Chicago. So many new things are being developed and being done by this industry. So these are some common rapid prototyping technologies, um, and I have been part of many of these. Like I was part of the first group at um, a company called Advanced Ceramics Research, as well as Rutgers University, where we built the first ceramic rapid prototype. Many different technologies being done. Anyway, I will describe one after the other, and I will do that in the next set of slides, next set of lectures.